Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study the parameters of operational amplifier, and in this lecture we are going to study the two important parameters, that is virtual ground concept of operational amplifier and frequency response characteristics of operational amplifier. The first parameter of this video lecture, that is virtual ground. The circuit diagram of virtual ground is now displayed on your screen. First of all, what is virtual ground? What is virtual? Virtual means it is imaginary. In actual practice, it will not happen. So we are going to imagine how it works. So virtual ground, that is the imaginary ground. The circuit diagram of virtual ground is displayed on your screen. In this case, in this operational amplifier, the two input signals, that is V1 and V2, are applied to inverting input terminal and non-inverting input terminal respectively. Then plus VCC and minus V, that is operating potentials, are also connected to this. V1 is the inverting input potential while V2 is a non-inverting input potential. The difference between the input potential, that is V1 and V2, is known as differential input voltage, because mostly op-amp is work in a differential mode. The common mode is mostly, we are going to avoid that common mode inputs. The gain of the operational amplifier is given by, what is gain? Gain is nothing but it is a ratio of output to the input. So A is equal to V output upon V input. In case of ideal op-amp, the gain of the amplifier is infinite. So obviously A is equal to infinity. Therefore, V output upon V input, that is the gain. So V output upon V input is equal to infinity. So obviously, when gain becomes infinity, when input potential becomes 0. That means when V input is equal to 0, then only the gain of the amplifier becomes 0. That means V output upon V input will be infinite. But friends, in this case, the differential mode is used. So what is the input potential? What is the actual input potential? That is the difference of input signal, that is V1 and V2. So V input is equal to V1 minus V2. So obviously V input is 0, therefore V1 minus V2 is equal to 0. So V1 is equal to V2. V1 minus V2 is equal to 0. V2 equation च्या पलीकडे गेलं, so आपल्याला मिळणार आहे V1 is equal to V2. That means in this case, the inverting input potential and non-inverting input potentials are equal. V1 is equal to V2. So inverting potential and non-inverting potential are equal. That means the inverting input terminals and non-inverting input terminals are short circuited and then a common input is applied. But friends, in actual circuit diagram, V1 and V2 are the two different potentials. And V1 is applied to the inverting terminals and V2 is applied to the non-inverting terminals. There is no short circuited. But by this equation, it is clear that V1 is equal to V2. That means the input terminals are short circuited and they are considered as virtually short circuited. They are imaginary short circuited. In actual practice, they are not short circuited. But in imaginary, we are going to short circuited the two input terminal, that is V1 and V2. That is virtual short circuit. In actual circuit diagrams, in actual application of op-amp, mostly the non-inverting input terminal is grounded. The circuit diagram is already displayed on your screen. In this diagram, it is clear that the input signal is applied to the inverting input terminals through input resistors Ri. Output is feedback to the inverting terminals through feedback resistor Rf, and the non-inverting terminal is grounded. So in this case, as non-inverting is grounded, inverting input terminal is considered as virtually grounded. Sorry. Non-inverting is grounded and inverting terminal is connected to the input signal through input resistor Ri, but that terminal, that is inverting terminal, is considered as virtually grounded, hence the potential drop across this terminal is considered as zero. It is not grounded, it is a virtually grounded. That is a concept of virtual ground. And this virtual ground concept is useful to solve or to derive the expression of amplifiers. When we are going to derive the expression, then this virtual ground concept is very useful. So friend, that is virtual ground. Our next parameter is a frequency response, or that is a characteristics, frequency characteristics, and that is the characteristics of frequency and gain. The frequency is given in 0, 10, 100, 1K, 10K, 100K and 1 megahertz, while the gain, that is 20, 40, 60, 80 and 100 dB. The gain is always measured in decibels, while the frequency is measured in hertz. From this graph, it is clear that, from this frequency response graph, it is clear that at low frequency, the frequency is low, at low frequency, the gain of the amplifier is very high. And as the frequency increases, as we are going to increase the frequency, the gain of the amplifier continuously decreases. The frequency increases, gain falls at regular rate. Frequency increases, gain decreases. The graph pattern is like this. The gain decreases. This rate of fall of gain decreases. This rate of fall of gain is known as roll-off, because a structure of that characteristics is like a roll. That is known as a roll-off. And at any point on this graph, on this roll, at any point, the product of gain and the frequency, gain is on y-axis and frequency on x-axis, and the product of this gain and frequency, that is known as a gain bandwidth product, is always constant, because as frequency increases, gain fall at a regular interval, at a regular rate, but their product is always constant, and this product is known as gain bandwidth product. Now we have to find out the unity gain frequency or unity gain bandwidth. The unity gain bandwidth of op-amp is 1 megahertz. It is a high frequency, because at this frequency, the gain of the amplifier, gain of the op-amp is 1. That's why it is known as a unity gain frequency. It is also known as the unity gain frequency. For very high frequency, gain of the op-amp is very low, and at very low frequency, gain of the op-amp is very high. The bandwidth of op-amp. What is bandwidth? Bandwidth is nothing but a difference between higher frequency and lower frequency. Lower frequency and higher frequency. It is a difference between lower frequency and higher frequency. So it is given by FH minus FL. Higher frequency, FH. Lower frequency, FL. So it is a difference between FH and FL. But friend, in this characteristics, FL is 0. So obviously bandwidth is equal to FH. That is a higher frequency. And this higher frequency, FH, is also known as cutoff frequency. What is cutoff frequency? The cutoff frequency is a frequency at which the gain of the operation amplifier is 0.707 times its maximum gain. The frequency at which the gain of this circuit, gain of this operation amplifier is 0.707 times its maximum gain. That is cutoff frequency. And friend, that is a frequency response. So in this video lecture, we have studied virtual ground, that is imaginary ground, and the frequency response curve or frequency response characteristics of operation amplifier. In next video lecture, we are going to solve, we are going to solve the expression of operation amplifier. The first application of operation amplifier, that is inverting amplifier, and in this video lecture, we are going to find out the expression of inverting amplifier. So friends, keep watching our video lectures. Bye, take care, see you again in next video lecture, in which we are going to study the inverting amplifier and we are going to derive the expression of inverting amplifier. So bye, take care, see you again.